Hello, Assalamualaikum, and good afternoon, good evening, everyone. In this video, we are going to discuss about first order linear differential equation, specifically on separable and linear equation. But before that, let us try to recall what we have done during your introductory or elementary calculus. Previously, you have been introduced on differentiation and integration, so that is during your elementary calculus. Okay, differentiation and integration, so that, for example, if you have a function y as a function of x, y equals to 2x, and then you want to find the derivative, the first derivative of y, or the slope of the tangent line of the curve y. Okay, so that what you need to do is you need to find dy dx. Differentiate y with respect to x on your left hand side of your equation give you dy dx, while differentiate 2x on your right hand side of your equation give you 2. So that this is differentiation. Okay, so what about integration? So integration is antiderivative, means that you have derivative, you have differentiation, and then you need to find the solution. The solution means that a function or an equation that satisfies your differentiation just now lah. Okay, so what you need to do is you need to integrate both sides of the equation lah. So differentiate dy dx with respect to x will give you y, while integrate your right hand side 2 with respect to x give you 2x plus a constant c. Since this is indefinite integral, so that you need to find or add an unknown, we call it as c, or whatever unknown that you can represent here, for example a, b, d, e, so whatever unknown that you want to put it here. Okay, so we don't know what is the value of c. Okay, so the solution that we have here, we call it as the general solution, where your c, okay, your unknown, takes no specific value. Okay, when c has specific value, so for example, given an initial condition, for example, y equals to 2 when x equals to 0, so that you have this solution. So substitute y equals to 2 when x 0, so 2 equals to 0 plus c, so that c equals to 2. So now your c takes specific value, which is 2, c equals to 2. So substitute back into your general solution just now. I name it as GS, general solution, so that you have y equals to 2x plus 2. So what we call this equation is no longer called as general solution, but we call this equation as particular solution. Okay, particular solution. Okay, penyelesaian khusus. Okay, so this is our solution. Okay, solution means that this equation satisfies your differentiation just now. Okay, so that is the elementary calculus that we have learned, or we have been introduced during our engineering mathematics 1. Okay, so now we want to talk about differential equation. Okay, in EQT 102 we want to talk about differential equation. Okay, so what is differential equation? Differential equation means that you have an equation. Okay, you have an equation, for example, y plus 3xy equals to 5. Okay, for example, this is just an equation. But what about differential equation? Differential equation means that you have an equation and your equation must have derivative. Okay, derivative. So we can say that, for example, dy dx. Okay, this is derivative. Okay, plus 3xy equals to 5 is differential equation. It is actually an equation, but your equation consists of derivative, so that is differential equation. Okay, so now we can say that dy dx, okay, we can say that dy dx plus 3xy equals to 5 also can be written as this one, y prime plus 3xy equals to 5. So this is also called as differential equation. So where your equation consists of derivative here. This notation, okay, derivative, only one. Okay, single derivative here, single derivative or just dy dx, we call it as first order. The order is 1. So we call it as first order differential equation. Okay, if you have d square y dx square plus 3xy equals to 5, look at your equation. This is an equation, but your equation consists of derivative here. This is derivative, so that this is differential equation. And look at the order. The order is 2, so that we can say that this is second order linear differential equation. Or we can say that this one we have double derivative. So you have 2 tick here. Okay, so that we call it as second order or differential equation of order 2. Okay, so that is differential equation and order. Okay, for example, let's say you have dy dx, okay, plus 3xy equals to 5. So this is an equation or differential equation with order 1, okay, order 1, and the degree is also 1. Okay, because the highest derivative here is 1, and then the degree outside here is also 1, so that this one is first order and degree 1. For example, let's say you have d square y dx square plus dy dx of cube plus 3xy equals to 0. For example, let's say this is also called as differential equation. Look at the order. What is the highest order in this equation? In order to look at the order, so that you check the highest derivative, okay? The highest derivative, but this one is dy dx. Only 1, order 1. Okay? This is of order 2. So you have second derivative here, so that you can conclude that this equation is of order 2. When you look at order 2, so look at this equation. Okay, what is the degree? So the degree is also 1. So this one is order 2 with degree 1. You cannot say that this is your order, the highest order, because this one is order 1. This one is order 2. Okay, but this one is with degree 3. This one with degree 1. You cannot say that this one is order 2 with degree 3. No, you cannot say that, because whenever you want to determine the degree, you must refer to the highest order or to the highest derivative. Okay, the highest degree must be referred to the highest order or highest derivative. So that is how you determine order as well as degree of a differential equation. Okay, so now we move to, I mentioned here is initial value problem. Okay, what is initial value problem? Okay, class, so look at here. I just show you the differential equation. This is a differential equation with order 1. Okay, because the highest degree is 1. Okay, what is initial value problem? Initial value problem means that you have a differential equation here. You have a differential equation. I note this as DE. It must come together with initial condition. When you have initial condition, so that we call it as initial value problem, or sometimes we call it as IVP, initial value problem. Okay, so for example, if you have dy dx, look at this equation. Okay, dy dx plus 3xy plus 5. So this is a DE. Okay, so this is a DE. You have a differential equation here. So this differential equation must come together with initial condition. For example, y equals to 2 when x equals to 0. See? Now, you have a differential equation. Let me write here. Okay, you have a differential equation comes together with initial condition, so that we call it as initial value problem or IVP. When you just have differential equation like this, we just call this as a differential equation. Okay, when you have first order, so that we call it as first order differential equation. When you have differential equation combine or comes together with the initial condition, so that we call it as IVP, initial value problem. So by now, I really hope that you have some idea on the differentiation between differentiation, integration, differential equation, initial value problem, as well as the definition of order and degree. So without further ado, so let's talk about our first chapter. Okay, our first chapter is first order linear differential equation. Note that when we talk about first order linear differential equation, so we have a differential equation. Okay class, so we have a differential equations here. Okay, when we talk about first order, so that the highest derivative or the highest order in your equation or in your differential equation is 1. That is the highest order or the highest derivative. So now we want to look what are the types of first order. Okay, we have 4 types of equations. The first we call it as separable, and then we move to homogeneous, and then we move to linear, and the last one is exact equation. Okay, in this video, okay, I'm going to show you only on separable, okay, separable and linear equation first. The next video, then only we talk about homogeneous and exact. So let's talk about separable equation. Okay, now let's talk about separable equation. Okay class, I'll give you one tips here. Since we have 4 types of equation, which is separable, linear, exact, homogeneous, so that we have 4 equation, right? So when we have 4 types of equation, so the first step is you must have the ability, or you must be able to identify. Okay, the first step, you must be able to identify what is the type of the equation. Okay, when you just look at the equation, automatically in your mind you know that, oh, I have separable equation, oh, I have homogeneous equation, oh, this is a linear equation, or oh, this is probably exact equation. Okay, so the first step is you must be able to identify the type of equation. So how to identify? So now we move to separable equation. The first one, how to identify that you have separable equation. Okay, you will have a separable equation, or the equation is called separable if you have an equation in the form of dy dx equals to g of x times h of y. For example, you have dy dx equals to 2x. 2x is a function of gx lah, as a function of x, and then hy is a function of y. For example, you have 2xy. Okay, that is in this form. Okay, or if you have dy dx equals to gx over hy. For example, dy dx equals to 2x over y. Okay, and the last one, if you have and the last one, if you have dy dx, okay, dy dx equals to y over 2x. So when you have an equation of first order differential equation in these 3 forms, so that you can say that, oh, I have separable equation. So when you identify or determine that this equation is separable, the next step is you need to rearrange the equation. Okay, rearrange the equation in the form of this one. Move all the y variable to your left hand side of the equation, and then your x variable to your right hand side of your equation. Okay, y to your left and x to your right. Okay, and then you just integrate, and then you get the general solution. Okay, when you just integrate, and then the solution that you have, you need to plus a constancy. So the solution that you obtain, we call it as general solution. If the initial condition is given in your question, okay, so that you have a DE, okay, and then given initial condition, so that your equation becomes IVP, okay, initial value problem. So when you have initial value problem, the final solution that you want to find, we call it as particular solution. Okay, so now let's try to solve for one example here. So we have solved the differential equation. This one, dy dx equals to 4x over 3y squared. So it's 3y cubed. So this question looks easy because automatically we know that this is a separable equation because of this equation in the form of dy dx equals to gx over h of y. Okay, so the step tells you that when you have a differential equation in separable equation, so what you need to do is rearrange the equation. Okay, where you need to bring all the y variable to your left and x variable to your right and then integrate both sides. Then you have a general solution. Since this equation does not mention or does not give you any initial condition, so that we just want to find the general solution. Okay, so try to rearrange this equation so that we have dy. So your y bring to your left so that we have 3y cubed dy equals to 4x dx. Since we want to find the solution of differential equation, we want to find what is your y. Okay, where this y must satisfy your differential equation. Okay, so we want to find y. So I don't like to put any constant in front of my variable y. So what I want to do here is I just bring 3 here. Or if you want to remain 3 on your left, it's also okay. So now I have y cubed dy equals to 4 over 3x dx. I already rearranged this equation. So what I need to do next is integrate both sides of the equation. Will give us what? Integrate y cubed give us 1 over 4 y to the 4, okay, equals to 4 over 3. Okay, 4 over 3, I just remain 3 for a while, and then I have x squared over 2, right? So over 2 times 3 here, so you have 4 over 6, okay, plus a constant c, so that I have y4 equals to, this one is I can have 4 brings to our right, so I have 4, and then I have 4 over 6. 4 over 6 is 2 over 3, right? So I have 2 over 3 x squared plus c, so that I try to simplify so that I have y equals to 4 2 over 3 x squared plus c, and then I have 1 over 4 here. Okay, because I just want y on my left. If you wish to find only y to the 4 on your left, so that you can see that this is your general solution, I also can say that this is my general solution. Okay, both are the same. When you substitute back your equation here, the solution, we call it as solution. This solution must satisfy your differential equation. So how to know that this is your solution? So what you need to do is you need to differentiate once your solution, so that your left hand side you have dy dx, right? So differentiate your right hand side of your equation so that you have something lah. For example, you have alpha. For example, when you differentiate your right hand side, let's say the name is alpha, or the value that you get is alpha, and then you substitute alpha on your left hand side of your equation. Check whether your value of alpha here, your left hand side, is it equal to 4x over 3y cubed? If alpha equals to 4x over 3y cubed, so that your left hand side equals to your right hand side, so that we call it as this equation or this function is your solution, where your solution satisfies this differential equation. So that is how you can always check the solution. So we call it as concept of solution. I really hope that you can understand on how to prove that you have the correct solution here. Okay, let's move to the second one. Okay, the second example asks you to find the particular solution. Why? Because this question consists of differential equation as well as initial condition. So sometimes we can write the question as solve the differential equation of blah blah blah, and given that blah 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 the condition, or otherwise the question can ask you simply like solve the following IVP. Solve the following IVP: y prime equals to 4x square y, and then comma here, and then you have y equals to 2 when x equals to 0. Okay, simply like that. Solve the following IVP. So what we need to do is, the first step, we need to we just ignore first our initial condition. So what we concern here is we want to solve for the differential equation first. Okay, so in order to get particular solution, our aim is we need to find general solution first. Okay, so how to do this? First, we need to identify whether you have separable equation or not. So this is obviously in the form of separable equation, where you have dy dx equals to 4x square y. This is gx, or g of x, times h of y. Sorry. Okay, so now I just rearrange, okay, so that I have 1 over y dy equals to 4x squared dx. So what I want to do next is I want to integrate both sides of my equation, where I will get integrate 1 over y. dy will give us natural log y, okay, equals to 4 over 3 x cubed plus c. Okay, I want to simplify my solution. I don't want natural log y, I just want to find y. For example, I just bring this one here. Okay, in order to get to eliminate the natural log, so I just take exponent both sides of my equation. Okay, so that I have exponent natural log, so that I just have y. Oh yeah, I already get y on my left hand side of my equation. So let's take a look what happened to our right hand side of our equation. So that we have exponent 4 over 3 x cubed, and then plus c. This is equivalent to exponent 4 over 3 x cubed times exponent c, right? So we already learned this during our secondary school or high school, where this is in topic of indices. Okay, logarithm indices. Okay, so that we can say that exponent c is just a constant, we call it as a. Okay, exponent 4 over 3 x cubed. Note that a is exponent c, so that I have this y. The solution that I obtain here is general solution. Okay, general solution. But now the question asks you to find the particular solution. So in order to find the particular solution, you need to substitute the initial condition. The given initial condition tells you that y equals to 2 when x equals to 0. Okay, so what I do is I just substitute into my general solution, so that I have, okay, 2 equals to a e 4 over 3 0 cube. Exponent 0 gives us 1, so that I have a times 1 is a, your left hand side is 2, so that I can conclude that a equals to 2. When my unknown a takes specific value, which is 2, so that I can obtain the particular solution by substituting the value of unknown into my general solution, so that I have y equals to 2e 4 over 3 x cubed. So this is my particular solution. Okay, so this is just a simple idea on separable equation. Okay, on exercise 2.1, what I want you to do is please try this one. Okay, this equation is initially we cannot say that this is separable equation. Okay, so what you need to do is you try to simplify. What I mean by simplify is you can try to what we call it as simplify, factorize. So you can factorize try to factorize this equation. Okay, when you try to factorize and then look, is this equation in these three forms? Adakah dia dalam bentuk three forms? Form 1, form 2 and the third form. Okay, and if the factorized or simplified version of your equation here in the form of either one of the previous general formulation, so that you can try to bring your your y variable to your left, and then the x variable remain on your right hand side of your equation, and then integrate, then you can get the general solution. Okay, the second equation, is you have 1 over x square plus 1 dx. Okay, and then you have equals to ex plus y is ex dot ey. Okay, but this one is dy dx. Oh, I think this question left on one information here. Okay, please, on your right hand side, please add one information, which is exy dy. Okay, is separable or not? If yes, solve it. Okay, if not, so just leave it. Okay, so that is the end of separable equation.